between the pages that makes it matter. All right, so.
Oh,
Motivational.
I know, right?
You should have that, like every day, just put it in.
I know, but that's, then it becomes tedious and it's no longer just inspirational in that moment. You're like, all right, okay, I haven't had enough coffee yet. I am feeling pretty emo. Inspirational.
Don't die.
Don't die.
Right.
Or that way.
Your dog will be sad.
That way.
I don't have a dog, I'm allergic to it. Then no one's sad. Okay, so let's go ahead and take a look at this. So I'm going to try and finish up this as much as I can. I'm going to skip a couple of the examples because we have to get through all this stuff. So we're supposed to be like done with everything after spring break. And guess what? We have one more week till spring break.
Yay.
But since we're still in 8, we need to be at 11. Okay, but guess what? I also skip a couple in between there. So 10, 11 is kind of combined. And so I do like 10, 1, 10, 2, then 11, 3, and yeah, anyway. So it's just for the AP exam. The book is made for everyone in calculus, but the AP exam just like hits certain orders. Anyway, all right, show the following sequences diverge. Okay, so now let's pretend I'm gonna remember what I did yesterday. So I would do the what of what? The what?
The limit.
Thank you. So it's going to be the limit of x approaching of
1 plus negative. What?
I'm sorry, it didn't work out very well. All right, so 1 plus.
Be negative 1 to the x power.
Nope. The limit as.
Oh, okay. X purges of negative 1. Oh, negative 1 to the x.
Oh yeah, to the x. Sorry.
X, but yeah. We get it.
Yeah. Okay. So there we go. X. There we go. All right. So limit as x going to infinity of 1 is just going to be, say 1. 1. But plus this piece over here. What's happening to this? What's happening? Okay. Let me give an example. First power. Say negative 1.
Negative 1.
Okay, second power. Third power.
Negative 1.
Fourth power.
Positive.
Fifth power.
Negative
12th power. Okay, see the point? What's happening in between those?
Isn't constantly go from negative.
It's alternating, right? So alternating. So since this thing right here is alternating, it's not going to a limit, right?
Right.
It's alternating in between these 2 points so that it's not going to a limit. So therefore, this piece right here has no limit, right?
Uh-huh.
This one's limit does not exist, right?
Right.
So 1 plus does not exist means it's going to be divergent. So if the limit doesn't exist, it's going to diverge. Okay, what about this one? I think I talked about this one already once. So, think about it. As I go to infinity, what's that answer? Infinity. So for that one, it's going to go like 1, it's going to be 1, 2, 2, 3, 3, and it's going to keep going up, right? There is no maximum on this, right? So therefore, this goes up to infinity, so therefore it is divergent. It is taking the limit, and it is as it goes to infinity, and it does not go to a number. All right, so geometric sequence right here, where r is a real number. If it converges to 0, if this happens. Converges to 1 if this happens. Okay, if diverges for all other numbers. Okay. So, let's try this one. So, we're going to say that this is basically going to be that first item, right? the first item should be from where to where? It should be between, right? R has to be between here and here, right? Okay, good. Let's set that up. So it's going to be, let's see, I have -1. Was it equal to also? Nope, not equal to. Okay. And it's 3 over 4 and 1. Yes?
Yes.
Okay, so let's see. Converges to 0 if that works. Does it say that I have to input the n in there? No, I don't input the n. Okay, so let's look at it then. So is that going to be true? Is 3/4 less than 1?
Yeah.
Is 3/4 greater than -1?
Yes.
So this is going to be convergent. Okay, what about this one? -1 to 4 over 3 to +1, right? Yes. Convergent? No. Okay, now for the people that are not very good at math, I would multiply both sides by 3, right? So this would be -3 less than 4, and that would be 3. Is that true? No. Okay. So just because some people have, fractions are not their friends. All right, so right here, there are other ways to show that sequences converges and diverges. To explore these, we need to define bounded sequence and monotonic sequence. Bounded sequence is bounded above if every term in the sequence is less than or equal to some number m, capital M, okay, is going to be, so it's basically the maximum, the capital M. So it's going to be bounded above with capital M for this, for all numbers, it's going to be there, okay? So it's going to be bounded for that. So the sequence is bounded from above. Similarly, S and N is bounded from below if every term in the sequence is greater than or equal to M, that is, for this number right here. Okay, S and N is lowercase m, so lowercase m would be bounded below. Okay, that would be like the minimum. Maximum capital M, minimum lowercase m. Make sense? Yeah? Good. Okay, so bounded in between those things. So here's the one that's actually bounded below, lowercase m, sequence is bounded below. For example, since S of n is equal to cosine n, which is less than equal to 1 for all n, the sequence S of n is equal to cosine n is bounded above by 1, and since S of n is greater than equal to -1 for all this, it is bounded below by -1. Does that make sense? It's a sine wave, right? So or a cosine wave, cosine wave. So cosine wave goes up to +1, goes down to -1. So it's bounded in between those two places, right? So that goes along with like my squeeze theory. Squeeze! All right. Anyway, okay, determine whether a sequence is bounded from above or bounded from below. The sequence of this is bounded from both above and below because, in this case right here, so we turn this into, we multiplied everything by n. I'm sorry, 1 over n, sorry. So it's like this, I don't know why. 1 over n over 1 over n. So what that's going to do for me is going to cancel out a whole bunch of stuff. So it's going to get rid of my n in the numerator. Okay? So it's going to get rid of the n in the numerator. So when I do that, that's how I get my just 3 over 1 over n. So when I distribute here, that's going to cancel. So I'm left me with just 1 plus 2 over n. Okay, so now that only gives me 1 n here. So that's going to help me out so much. That's going to help me out so much. And so for now, this one is from here, as this goes to infinity, right? this goes to infinity, this goes to 0, and this is going to be 3, right?
Yeah.
So it would be bounded above there. And for this other one over here, so this one right here, and this for all n that is greater than 1, okay, this is less than, this is going to be greater than, so 1, so this is going to give me more here. So this is going to be 3, let's go 3 and over 3, right? So n's greater than or equal to 1. Okay, what would the next one be? 6 over 4, right? Okay, keep going, and next one's going to be 9 over 5. So in this case right here, why is this one written differently? So it's got to be greater than 0. So 0 is for this, and I don't like that. Huh?
I don't like tearing there.
No, I'm gonna show this. So we are going to have, so it was 3 control divide 3x over x plus 2. Okay, so now from right here, so from this point right here, it is going to be bounded right here on this one. It would be above for numbers over here on this side. So it would be above here, and it would be below here. So numbers that over here that are actually on this side of the asymptote, which would give me 2, right? Or negative 2? So from negative 2, I think that's missing from the notes. Okay, so from negative 2, this would be bounded below. So it's actually going to go to this point right here. So it's going to go to an asymptote on this side right here. So it's bounded to that. Okay, so on the left side of this is going to be bounded below, so it can't go any lower than that, right? On the right side of this asymptote, which I would have right here at negative 2, it's going to be bounded above, so it can't go any more above this right here. Now, does that make better sense? Or did I just, like, blah, meh? No?
Yeah, but how do we show it?
How do we show it? Okay, so on this one right here, I think the notes were actually copied down wrong. So we have this one right here. So we could get 3 on this side. Okay, this actually has to do with numbers that are going to be less than, n's that are going to be less than 3. Okay, numbers are less than 3, but now numbers that are greater than, here, so this would be, okay, because this is above and below, so this one right here, like I said, I really think when I wrote this down, I missed a step on there. So from this one right here, so it'd be where I have it's not equal to negative 2, right? So all numbers that are going to be less than that, right? So all numbers less than that, so that's going to be, so for x's that are going to be less than negative 2, it's going to be bounded, below. On this one right here, since we did this right here, and I start plugging in numbers for that, so as we go this way, it's actually getting more and more down to the 3. Okay? There's also going to be some type of asymptote there. Okay, so it's bounded above, below on this one, and now this will also on the right hand side where x is going to be greater than negative 2, x is going to be greater than negative 2, it's going to be bounded above on that one. Does that make sense now? So we found the asymptote and we said, hey, this is going to come out to here, so it's going to be less than that. What did I miss when I copied that down? Okay, so yeah, I missed something on that one. All right, so let's take a look at, oh, here's the things for it. So this is 12, 11, 12. Okay, this shows different parts right here. So this one right here is one of the functions. This is going to be bounded above here. Okay, this one right here, this is, for this problem, this one right here is going to be bounded below. So for this one right here, it's all going to be down to this one right here. So it's never going to go below that one. And for this over here, if you notice, this one is alternating because it's going here, 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 here. That one's alternating, so that is neither bounded above or below. Okay, there's no bounds on it. As this one keeps going, it's going to keep getting bigger and bigger and bigger, right? It's going to keep alternating. So this one's unbounded. Oh, crap. I think that was part of my other one. Okay. I gotta go back and re-look at my notes. Sequence is, S of n is bounded if it is bounded both from above and below. For a bounded sequence, there is a positive number k for which S of n is less than or equal to k. Okay, so that's going to be my bounded above and below for all n's that are going to be greater than or equal to 1. For example, the sequence S of n for this one right here is bounded since this was here for all integers that were going to be greater than equal to 1. So integers, lowercase n, that means the series. So that's going to be 1, 2, 3, 4 that were going into there. For this, all my terms, those are going to be bounded. They should all come out to be less than the number 3, right? Okay, so theorem. The boundedness, yes, that's a word. Theorem, a convergent sequence is bounded. Okay, the convergence of boundedness theorem is not true. Bounded sequences may converge or they may diverge. For example, the sequence here is bounded, but it diverges. What? Did I just say that one was unbounded? Yes. No, it says it's bounded.
So if it's convergent, it's bounded, but if it's divergent, doesn't mean it's not bounded?
This one is not going to, I don't understand how this one's going to be. Oh, it's bound. Okay, I'm sorry, this wasn't the previous one. I was thinking it was this graph right here, but it's actually not. This is the previous one that I did earlier. So this one, so for every exponent, remember when we did the limit right here? So it's going to be positive, negative. So for my first term, 1 would give me what? 0, right?
Yeah.
Second term is going to give me 2, right? Third term, 0. Fourth term, 2. Fifth term, 0. So this one is bounded. I'm sorry, I thought it was a previous one. This one is bounded because it's only going in between my 2 and 0, right? So it is somewhere in between there and there. So it's bounded, so it's only going to go all the time in between those two. They're bounded, but since it doesn't have a limit, it doesn't go to one number, therefore it has to be divergent. Okay, here's the proof that goes along with this to actually explain the whole thing with the absolute value of the limit for why it would be bounded. Okay, I threw this in there for you because I did not explain it very well the other day. Test for divergence of a sequence. If a sequence is not bounded from above, or if it's not bounded for below, then it diverges. So if it's not bounded for either, then it's going to diverge. Okay, so for example, sequence negative n is not bounded from below, and the sequences here, here, and here are not bounded from above, but so each sequence is divergent. Okay, these things are very important. Okay, I threw them in the notes. Okay, if any of the above conditions hold, the sequence is called monotonic. Okay, so this is important as we go. So if my increasing or decreasing, so super important. We're going to go back to this. Okay, 3 ways to show sequences is monotonic, the algebraic ratio, and the derivative. Okay, show the derivative of a related function is negative for all x greater than equal to 1. Okay, to show if it's decreasing, show that it is increasing. Show the derivative of a related function is positive for all x greater than equal to 1. Test can be extended to show sequences is non-increasing or non-decreasing. This one right here. Crap. What do we have left? 5? Dang it. Okay. So I don't know if I could actually get through all these.
Like 4 slides.
I know. I gotta get to these tomorrow because I'm not gonna get enough time. All right, so sorry, I will be here after.